And this one has to do with ions. You have two ions, cations and what? Anions. Okay? An ion can be an atom or group of atoms that appears to be what? Charged. Electrically what? Charged. Either positive charge or negative charge. Okay. Ionic reduces the distance between the nucleus and the outermost shell of an ion. Now we are not talking about an ion. An ion. Okay, let's see. We have sodium atom. This is sodium atom, isn't it? Then we have sodium ion. Now if you are asked which of these two appears to be bigger in size, which one appears to have more ionic radii? Is this sodium atom or sodium ion? Let's check. Let's see. Always be a check. There will always be a check. How many number of protons appears to be here? Plus 11, isn't it? But I'm doing plus because it's positive. How many electrons are here? Plus 11, Abi. So there is equal. So the attraction will be equal. It's not like case where one is more than the other one. So coming over here, how many protons do you have here? Still 11, Abi. How many electrons do you have here? It's now 10. It's all lost now. Oh, for away from this, for it to form this, it has lost electron. For this to form ion, that means this has lost electron. This loses an electron. This, see the electron loss here. Are you seeing it now? So now, which one will tend to pull the electron? Which one will try to have the highest pull of electron? Is it this or this? Which one has more charge, more positive charge? There are more charge here. You see, this positive charge is going to grip everything here without remainder. This is going to grip everything. You can see it can grip every of the electrons. Okay, and then also willing towards grip more, because it appears that this ion, this cation here, appears to have more number of protons than what? Electrons. When the higher the nuclear, this is nuclear charge now. The higher the nuclear charge, the smaller the size now. Okay, this one has smallest size. This is going to be small. It's going to be what? Bigger. This is bigger than this, or this is smaller than this. Why? This has more what? Nuclear what? Charge than this. The difference here is what is remaining is 1, isn't it? This is 0 now. Just like we are comparing with anion. There's chlorine, where you have proton. How many protons? 17. How many electrons? 17. Now, it gains electron to have what? Proton 17, electron what? 18. Just know that it's minus plus, isn't it? So see, I said, which of this one is going to be negative? This is anion, this is what? No, this is atom. This is what? Anion. I said, which one of this is bigger in size? Which one is bigger? The atom is bigger. Why is the atom bigger? The atom is bigger because the number of proton and electron appears to be the same. Here, the number of electrons is more than. So it means that the one that have more nuclear attraction is what? This one. So it means that an anion is smaller than its. Sorry. An atom or an anion. This anion appears to be bigger, isn't it? Because this we tend to grip, have more attraction. This will have attraction because they have more electrons. Then this proton will grip only 17, 18 will be screened. So that means the size will tend to be what? Bigger. So it means that an anion is bigger than its corresponding what? Atom. This is an anion. It is much bigger than, if the size of this is like this, then this size is what? Is bigger than this. Coming over here now, the thing is here, in this case, what happens between this and this? Which one is smaller in size? Which one is bigger in size? This is atom. This is cation. Is it the ion? Is it the cation is bigger, or that the atom is bigger than the cation? The atom here is bigger than the what? Cation. The atom here is bigger here, but the atom here is smaller here. Look at it well. It's simple like that. And then, okay, if you if you link it to the periodic table now, going across the period, supposing I have a case where I'm having ionic of, let's say, let me deal with few elements. Supposing I have something like period 3, we have Na plus, Mg 2 plus, Al 3 plus, Na 3 minus, O 2 minus, F minus. And you ask this question, which one here? You know what I mean? You know the relationship here. You know the relationship here? All these atoms you see here are isoelectronic. Are you with me now? Isoelectronic. Do you know what I mean by isoelectronic? They all have the same number of electrons. How many electrons are there in sodium ion here? 10. No. How many electrons? 10. How many here? 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 10. Species, substance with the same number of electrons are called isoelectronic. Iso means the same. So all the elements are isoelectronics. And the question now is, if this is like going across the period, what happened to ionic radius? They are all ion. Is it going to increase or decrease? This is where you now extract the proton-neutron ratios now. How many protons are here now? How many protons here? No, proton. Proton is what here? 11. Electron is what? 10. Proton is what? 12. Electron 10. Proton 13. Electron 10. And it's called for 3. Which one here is smaller in size? Smaller is aluminium. Okay, it has more proton. The higher the proton, the greater the charge. Smaller size, aluminium. That is the essence. That's what I'm trying to say. Let's continue. How many protons will be in Na3 minus? How many protons? 7. Electron 10. Here, proton 8. Electron 10. Here, proton 9. Electron 10. Between this, from here to here, which one will appear to be smaller in size? Smaller in size. Yes? Huh? It's 8, 9. Be looking very well. Be seen very well. So which one will appear to be smaller here? You said which one is fluorine? Fluorine. You'll be looking at the gap. The gap is much closer here. The gap is not that close here. I mean, so they are close gap. Look at the difference. Just 1 here, 2 here, 3. So that's why going across the period from left to right, ionic radius does what? Decreases. Just like atomic what? Radius. Ionization energy. Okay, how we first here? Well, of course, you know what is ionization energy? The energy. I didn't mean first. Let's look at first, just without adding first to it. What is ionization energy? No, don't say one more. Since what is it asked to define ionization energy, don't put any more. You know that ionization energy, is it exothermic or endothermic? Is endo. Energy required. Energy is absorbed, or energy absorbed to remove one loose electron from a gaseous atom to form a gaseous what? Ion. What if it is fixed? That means you're going to mention how many number of electrons removing. If it is fixed, that means it's going to be energy required to remove 1 mole of electron from 1 mole of an atom of an element in gaseous states. It happens in gaseous states to form a gaseous what? Ion. Fixed is when an element is to lose 1 electron. Just 1 electron. If an element is to lose 2 electrons, its energy is made available to take 2 away from an atom. That is what? Second ionization what? Energy. But you should know this, that energy that to remove 1 electron and that will remove 2 electrons, which one should be much greater? energy available to remove an electron, one mole of electron, and energy that will be available to remove 2 moles of electron from a 1 mole of an atom. Which one should be more?
2.
Energy to remove what? 2. That means ionization energy should be increasing across the period from what? Left to what? Right. From left to right. From left to right. But there are some anomaly, some discrepancies. Discrepancies just happen between this and this. Okay, normally, ionization energy of aluminium should be greater than that of what? Magnesium. That is how it's, that's normal thing. But no, rather, energy of magnesium is greater than that of what? Aluminium. Same thing happened between beryllium and boron. Energy of beryllium is higher than what? Boron. It's an anomaly. Same thing also happened between nitrogen. Where is nitrogen? Nitrogen and oxygen. Where instead of oxygen having higher energy of ionization, it is what? Nitrogen. It's an anomaly. Apart from these places, this thing happens. Normally, ionization energy increases across the what? Period. From left to right. Maybe I'll give one example. Let me use magnesium and aluminium, 12, 13. So these two, it could have been this, but now it's a magnesium. Why is in the electronic configuration? If you look at magnesium, electronically, magnesium is 1s2, 2s2, 2p6, 3s2. So it don't mean that the last subshell is already, it appears to be stable by having maximum number of electrons. So it's assuming stability, or what we call pseudo stability. Pseudo means false. There's a false stability here because this particular subshell has achieved maximum number of electrons. If you compare it with aluminium 13, we have 1s2, 2s2, 2p6, 3s2, 3p1. The last subshell is 3p1, isn't it? So it means that this p subshell is not filled. It's not filled of electrons. It means that the energy that will be available to remove this electron from this subshell will be much smaller compared to doing this, because doing this is like breaking the stability. This is not stable. So coming to something that is unstable, just small energy will just remove the electron, as simple as that. So that is the anomaly. So that trend doesn't augur too well between these two. So the reverse now become what? The case in this case. Same thing with oxygen and nitrogen. Nitrogen. Same thing happens beryllium and what? Boron. Now, apart from these places it happens, normally it should be increasing across the what? Board. Are you with me? Now, I want to say something about first ionization energy. If I want to define second, what I will now do, energy that will require to remove 2 moles of electron from 1 mole of an atom in a gaseous state. That will be second. And like you know, second ionization energy ought to be greater than that of what? First. Now the question, let me put up the question like this. First ionization of transition element, that's element in group 1. Let me use the example of sodium. First ionization energy of sodium and first ionization energy of magnesium. Which one is higher? First ionization energy of, will I say first? Let me use the word second. Second ionization energy of sodium and second ionization energy of magnesium. Which one is higher? Let me just explain. I think I have to do this first. I have sodium, I have magnesium. We're talking about second ionization energy that will be available to remove how many electrons? 2. So now, in this case, sodium is 11. So if you must remove an electron from sodium with 11 number of electrons, you're going to form Na+, isn't it? By removing one what? Electron. That means this sodium ion is now stable, isn't it? They're removing 2 electrons. What are you trying to do? They are trying to destroy stability. Like, anytime the stability is to be destroyed, energy to destroy stability will always be what? Higher. Are you with me now? So second ionization energy of sodium will tend to destroy its stability. It will try to destroy its noble gas configuration. Now it's like a noble gas. Now this sodium now assume the structure of neon, because this sodium and neon are isoelectronics. You know what I mean by that? they have the same number of what? Electrons. So you're trying to remove one more electron here to now achieve second energy of ionization. That is destroying. And even if that will happen, energy is required more than magnesium, where you will, if you remove 2 electrons here, that means here will now be what? 2 plus. Nothing like selenium 2 plus, because it means that the noble gas structure has been what? Destroyed. You need more energy. But in case of magnesium, to form magnesium ion, which number of electrons here is 12, isn't it? So removing 2 electrons from magnesium is like building a noble gas, not destroying. The energy to build is lesser than energy available to what? Destroy a noble gas. So in that case now, second ionization energy of sodium or alkali metal is greater than second ionization energy of what? Alkaline earth metal of group 2. Am I communicating? Because in group 2, you remove 2 electrons, you are building noble gas. If you remove 2 electrons from magnesium, you build magnesium ion, whose number of electrons now assume that of what? Neon, noble gas. The energy to do that is available, is not high. But for sodium, removing 2 electrons from sodium is just like, after the removal of 2 electrons, that means what remain, number of electrons remain 9 is not 9. That means you have now destroyed it from what? Noble gas structure of neon to that of what? Fluorine. Which, for you to achieve that feat, energy employed should be what? Higher. The energy may not even be available. The reaction may not even be feasible. So that's it. The energy to destroy a noble gas structure is much more higher than the energy to what? Build a noble gas what? Structure.